Okay, so in this video, we are going to prove that 1 is equal to 0 using some integrals. So here I have this complicated looking integral, and what we are going to do is we are just going to swap the order of integrals, and we'll see that we'll get different results. And we know that we can swap the order of integrals, right? So yeah, we'll basically prove that 1 equals to 0 using this idea. So let's just see how we can solve this integral first. The first integral we have is integral from 0 to infinity, integral from 0 to 1 of e to the power negative xy minus xy e to the power negative xy dy dx, right? So if I try to integrate this with respect to y, notice that the integrand will be y e to the power negative xy, and then from 0 to 1 dx. Now the way you can see this is if you differentiate this y to the power xy with respect to y, so this should be partial actually with respect to y, you see that this is just, first of all, you do product rule, so you get e to the power negative xy plus y times negative x with e to the power negative xy. That gives you e to the power negative xy minus xy to the power negative xy. So that's how we get this. Now, if we just evaluate your different numbers, we get e to the power negative x minus 0 dx. Now this one is easy, just an exponential integral, which gives us e to the power negative x by negative 1 from 0 to infinity. And that's 0 minus 1 over negative 1, which is 1. So we see that the first one gave us 1. Now if we try to evaluate the second integral, which is integral from 0 to 1, integral from 0 to infinity of e to the power negative xy to the power negative xy, right? Since the order is swapped, now we'll also have dx dy instead of dy dx. Now this one, just like the previous one, will be evaluated to, okay, the previous one was y e to the power negative xy, so now this will be x e to the power negative xy, which goes from 0 to infinity, and this is dy. Now if we evaluate this at infinity, we know that because the exponential is going to dominate this term, we will just have 0 minus at 0, since x is 0, it will just be 0. So we see that this is integral from 0 to 1 of 0 dy, and that's just going to be 0. So here we saw that the same integral, if we interchange the limit, gives us different answer. So that means this different answer should be same, and that proves 1 equals to 0. Definitely we know that this is not true. So now guys, it's your job to find out what's actually the problem with this argument. And yeah, do comment it down below. Thanks for watching, hope you enjoyed the video, and look forward to seeing you in the upcoming video too.